Of speed controlled by DC motor using the phase control converter. The speed of DC motor is controlled by the armature voltage, and the armature voltage is controlled using the different single phase AC to DC converter. Half converter, semi converter and dual converter are some of the thyristor based circuit which are used for the speed control of DC motor. Now the speed control of DC motor using the single phase full converter. This is the circuit diagram. In this circuit diagram we are using the 4 diode, and the working of the 4 diode is that it will operate in the mode 1 and in the mode 2. So yeah, and the speed of the DC motor can be controlled by varying the firing angle of the thyristor or the SCR. The speed of DC motor can be controlled by varying the firing angle of single phase full converter. Now the full converter will operate in the mode 2 mode. In the mode 1, the SCR S1 and SCR S2 will be in the on state, and for the mode 2, the thyristor and this in the mode 1, the thyristor S1 and S2 will be in the on state, and the S3 and S4 will be in the off stage. Now in the mode 2, thyristor S3 and S4 will be in the on stage, and the 2 SCR will be in the off stage. This means that the mode 1 will operate in the positive half cycle, and the S3 and S4 will operate in the negative half cycle, or mode 2 will operate in the negative half cycle. So the firing angle is used to control the speed of the DC motor, and by controlling the speed of the DC motor, the output voltage will be controlled. This is the block diagram of the speed of the DC motor using the converter. The block diagram explanation is that the driver circuit can be used to amplify the pulses and provided isolation using pulse transformer. Now the pulse generator. This is the microcontroller. And it is used to generate the pulses. Now the full converter. The full converter is used to convert the AC into the DC. This unit is used to detect the sine waveform. Now the second topic is the speed control of DC motor using the chopper. As we know that the chopper is a device which converts the variable DC output from the applied DC input. It simply chops fixed DC and generates the variable DC. So as the duty cycle is varied by varying on and off time of chopper, the speed of the motor can be varied. This means that by varying the duty cycle of the chopper, we can control the speed of the motor, or we can vary the speed of the motor. This is the block diagram of the chopper, and this is the waveform. As shown in the figure, when the chopper is on, the DC motor get the supply, and when the chopper is off, the DC motor will not get the supply. T on is the on time of the chopper, T off is the off time of the chopper. VDC is equal to T on plus T off, and this T on and plus T off is the total time of the chopper, and it can be written as the T. So T on upon T is known as the duty cycle of the chopper. So when the duty cycle is more, average DC motor supply to the motor is more, and so the speed of the motor will be increased. This is all about the speed of the DC motor can be controlled using the phase control converter and the chopper. Now we will start the speed of the DC motor can be controlled using the 3-phase induction mode.